So hello guys, today we'll discuss two questions from your ray optics point of view. Okay, so from your ray optics point of view, there is your question one and this is your question two. I am using some dark ink for your better visualization, or you can reduce the give me. So here you have two questions. So let's go to first question. A converging lens of refractive index 1.5 is kept in a liquid medium having same refractive index. Having same refractive index. What will be the focal length of the lens in that medium? Okay. So what is your question? There it is given कि one lens have refractive index 1.5 and a liquid of refractive index same 1.5. Okay. So this is your lens. Okay. Now you take your lens and one liquid in your bucket. Some liquid. So now take a lens and put it inside that liquid. So it has refractive index 1.5. It has refractive index 1.5. So what will happen? So what will happen? So actually you have observed कि if both the object have same refractive index 1.5 1.5, then the object will be invisible. Okay. So actually object will be invisible. You can't see the object inside that liquid because the both have the same color, almost same color. But let's solve it from the exam point of view. To solve this, you need your lens maker formula because it is asked the focal length of the lens in the medium. Okay. So what is lens maker formula? So lens maker formula says key lens maker. Lens maker formula says the focal length is equal to mu minus 1 by R1, radius of curvature of 1 and 1 by R. So here the mu, relative refractive index. Okay, here mu is mu2 by mu1. Okay, so here both the lens and the liquid have same refractive index. So 1.5 by 1.5 is 1. So your relative refractive index is 1 minus 1 by 1 by R1 by 1 by R2. So it is 0. So 1 by F is 0, which means your focal length F is infinity. So your focal length F is infinity. So I want to visualize what is infinity. Infinity means some plane object. This is a plane. Here you consider a mirror. Mirror have focal length infinity. Okay. So focal length will be infinity. What will be the focal length of the lens in the medium? Okay, it is infinity. The answer is infinity. Okay. So let's go to the second question now. Now go to the second question. How does the power of a convex lens vary if the incident red light is replaced by violet light? So the question is, what will be the power? What will be the power? Okay. What will power changes when the convex lens, it is a convex lens. Okay, you consider like this is your convex lens. And like this. Okay, this is a convex lens. So, if the incident red light is replaced by violet light. So now the light which is falling on your convex lens is red. Okay, I want to replace it red. I want to replace it with violet. Okay, so what is the change in power? Let's remember key the lens maker formula, which is 1 by f, is f power is mu minus 1 by 1 by r1 minus 1 by r2. So you don't need the information about R1 and R2. You need some information about focal length so that you can directly correlate your focal length, which is inversely proportional to power. Okay. So now you need information about the focal length. Ki how focal length changes with different lambda. Okay. Why I am saying this? Because red light have different wavelength. Okay. Red light have different wavelength and violet different. The relation Vibgyor. From Vibgyor, you know that red have larger wavelength than violet. Okay. So, first thing you remember कि red light have wavelength greater than violet. Okay. Second thing, the lambda wavelength is directly proportional to lambda is directly proportional to refractive index. So in your formula 1 by f is mu minus 1, 1 by R1 minus 1 by R2. So here the mu, so lambda directly proportional to lambda directly proportional to mu directly proportional to p because mu is directly proportional to p because 1 by f is directly proportional to p directly proportional to mu minus 1 means so so if the mu is higher, then the power will be higher. Okay.